Good afternoon, Physics 30s. Mr. Thompson here. All right, I have a little setup here for what we're going to be studying, which is about electromagnetism, how there's a circular magnetic field generated around a current-carrying wire. Okay, so let's get some of the specs here. So you can see I have a power supply set up there. I also have a multimeter. So I'm going to just turn on the multimeter and set this up. Okay? And what we'll do is we'll get some readings. So first of all, I want to find out how much current is flowing in the circuit when it gets closed. So let's set this up. Okay, wonderful. Now in the case of the current, let's see what we've got. Okay, so we have about 0.39. Let's move the light bulb out of the way so you can see it a little bit better. Okay, so the light doesn't get in the way there. There we go, 0.39 amps. And how much potential difference do we have? Okay, so let's just disconnect that. I'll just reconnect it to the switch here, and we'll close the switch. I'll adjust the multimeter a little bit, okay, for what we need. There we are. And so we've got about 15.25 volts. Okay. All right, so that's some of the information that we have. We have about half an amp, 0.4, and 15 volts. So we don't have a lot of current, but we do have some. So what I'm going to do here is I'm going to take a little moment to show you about the idea of a magnetic field around a current carrying wire. Once I get myself organized. All right, I have a couple little compasses. These compasses, of course, are pointing towards north, and compasses are really just little magnets on a pivot. And you can see that because they do have an effect on each other. Okay? Okay, but as you can see here, they're both pointing fairly to the right because the right, of course, is north, at least towards the south magnetic pole of the Earth. Okay? Now, with the switch closed here, what I can do is I can take the compass and hold it over top of the wire, and you notice it has this predominant turn to it, essentially facing towards me. Okay, there's its position at rest. Okay, and then notice there, going essentially perpendicular to the wire. Okay, trying to turn that way. Current's not high enough really to make it do that, but pretty close. This one here, notice tries to turn and point away from me. Okay, so what we can do here is we can use our right or left hand for conductors. And so what you do here, just to kind of simulate this, is you notice the black wire comes from the negative terminal and the red wire comes from the positive terminal. So I think about a flow of negative charge. I think about electrons moving essentially from this negative terminal to the left. Okay? You take your hand and you wrap your hand around the conductor with your thumb pointing in the direction of the current electron flow, left hand, and your hand circles the wire, showing that the magnetic field above the wire should be pointing towards myself as my fingers curl. Okay? If I want to think about the other way around and I want to look at the right hand rule, it works very much the same way. So what I'll do now is I'll grab a red wire, and instead of using my right hand, my left hand, I'll be using my right hand. So what I do with my right hand is I wrap it around the wire in the direction of positive current flow. Notice from this terminal towards the left. My hand curls around. Notice the compass down below is twisted and pointing sort of in this direction as the magnetic field should be above the wire. Okay? Thank you very much.